Hi folks, so in this video we are going to talk about functions, and we won't get into syntax yet. We'll just quickly cover what they are, what they do, and when and why they are so useful. So let's start with the description of a function. Function is a piece of code basically that can be invoked from anywhere in the program and any number of times. And when we say invoked, or there is another term call, it means basically start executing the statements of that function. So in some sense, it's basically a function is a small program which can do different things, and it can be a pure calculation. So for instance, it can take some input, calculate something based on that input, and then return an output value, which is called the result of that function. So that would be a pure calculation without side effects. And another instance example would be some transformation, right? It can take an input, transform the same input, and return nothing. So it basically means that the function doesn't return anything, but it has a side effect of modifying the input. So that's an example of transformation. It can have another side effect. So when we say a side effect, it's basically anything that happens other than modifying the input or making a calculation based on the input value or values. It's a side effect. So a function can have a side effect without affecting any of the program state. So it can be, for instance, printing something on your screen, on your console, or writing something in a text file, or even invoking some program or sending some request to a program running on another machine. So that means making a network call. So functions can do basically anything your program can do, a function can do. And as I said, a function is, think about it as a small program wrapped in some special syntax which makes it invocable. So from anywhere in your program you can call that function, which means your program will start executing whatever code is written in that function. So we'll get to the details of how to write a function, how to create a function, how to define it, and how to call it in the next video. For now, let's just go quickly through some examples and the benefits of the functions give us. So the very first thing, and the most, not the most important, but the most common, I would say, is the use of the function is to avoid duplicating code. Duplicating code means writing the same exact or similar code in your program more than once. So when you have a function, when you transform some piece of code into a function, then you don't need to repeat. Let's say if it's 10 lines, you don't have to copy paste those 10 lines n times in your program. You can just put these 10 lines in a function, and then wherever you need to call that, you just have one line which makes a call to that function. So that's one benefit. So remember when we wrote the program for calculating the square root using Arsen's method, we had this absolute value. We needed to check if the calculated result is within the error that we are looking for. We had this need to calculate the absolute value of some difference, and we needed that to in every iteration of the loop, which means if we just plainly write the logic of calculating the absolute value in the loop itself, it would actually, in the loop we would write once, since it's a loop. But imagine if we needed to call this absolute value to calculate it multiple times in the program. So we would copy paste that same code n times. Instead, we can just put that code into a function, call it absolute, which would take an input number and return an output, which would be the absolute value, and then just use that function. So that's one benefit, is code avoiding code duplication. So another thing which is similar to this, but it's a little different, is reusing the code, or reusing the functionality more precisely. So if your program is in a single file, reusing is the same as not having duplicates. But let's imagine if your program is built in or written in multiple files and by multiple people, then if you have one function, other people also can use it, right? Or even if it's not multiple files, you can, let's say you wrote some complex function which does something very useful and that some other people would want to use it. So you just publish your function. We don't know what publish means, but think about it as making it available for others to use. So you publish it, and then other people can just use your function in their own programs you would not even know about. So that's what the reuse is about. That's the second benefit. So one example would be, again, that square root. You wrote a square root with Arsen's method, and some people just don't know how to implement it. They just see, okay, someone wrote this already, there is this function they can call, and it would do what they want. So they would use that function. So another benefit that functions give us is basically the readability of your program. So when you have functions which are named properly, right? If the name basically gives a good description of what the function does, so it has a meaningful and descriptive name, then reading the program is much easier than if you would read just all the code that implements all this logic. So again, if we take the square root in this Arsen's method, right? If you just inline it, you have all the code. Someone reading that code who is not familiar with math, who is not good at math, they might not understand exactly what this code does. But if you just name a function square root or calculate square root, then obviously it means, okay, this code is calculating square root. They don't have to know all the details how it does it. Or another example. So let's say there is a small function which indicates, basically, given the year, so 1986, 2021, it says basically if this year is a leap year or not. So the logic of this calculation would be, if year is divisible by 4, so if it divides by 4, and either it divides by let's see, I think it doesn't divide by 100, or it divides by 400, yeah, something like that. So even I don't remember all the details, but the logic is, if you're not familiar with this, you might not know how this is done. So instead of that, instead of making this complex Boolean expression, you can just, even if it can fit in one line, you can just wrap it in a function and name the function is leap year. And that's it. So now your code, instead of reading this expression and thinking what it does, you have this one line saying, is leap year, and then the year. So I think it's pretty obvious what it does. So yeah, that's the third benefit that we get with functions, which is readability, basically. And with readability obviously comes maintainability, which means it will last the same person, like if I wrote the program in 2 months, if I'm reading the program, it will be easier for me to understand what it does. And moreover, if someone else is reading my code, it will be much more easier because they didn't write it, so they don't know all these details, how it's implemented. But reading the meaningful and descriptive function names make it much simpler, so they can know what it does. They can know if they can touch this part or not. So yeah, that's the third reason. Another reason is with functions, basically you can divide a task into smaller tasks, and which means you can basically give parts of this bigger task to different people to work on. So imagine if you have this long program, you don't know, like the programmers wouldn't know where one would stop and the next person would continue from there. They won't be able to run their programs individually to test it. So functions give that ability. If you can logically split a task into smaller tasks, and then each person can take these small logical parts and create a function which implements that part or task or subtask, and then the main program will be just a sequential invocation of all these functions, and that's it. And most likely the output of the previous function will be the input to the next function, and so on. So again, let's take an example. Let's say we're writing a scientific calculator program which has a lot of these complex functions, or not complex, but let's call them non-trivial functions, and each of them takes time and a lot of thinking to implement properly. So we give like 2 functions to one programmer, 2 functions to another, and so on, and then they can each work on their own on these subtasks or these operations. That's another benefit, and I think this pretty much covers most of the useful things. Another one I want to mention, it's a little more like not an advanced, but maybe not for this time, but I'll tell you anyway. So another good use or benefit is dividing code into layers, and let me try to explain this. So let's think about a big task, right? Let's think about building a house. So building a house on the very high level, we can think about laying a foundation, then floor, maybe depending on what type of foundation, then walls, then let's say there is a second floor, so there is a ceiling and the floor, or the floor of the second story, and then walls, and then roof. So we are thinking on this, and after all that there is like electrical wirings, there is plumbing, and then insulation maybe, and then finishing from both sides. So if we think on the very high level, these are all the tasks, but then each one also can be divided into its own task, right? Like laying a foundation might be like building this wired, or what is it called, the iron or steel structure for holding all the cement together, reinforcement structure, and then the wooden borders for holding or retaining the cement in place while it dries, and then pouring the cement, I don't know, yeah, a lot of other tasks. So that's basically becomes the second layer from the top, right? If we do top-bottom approach, top-down approach, then that's the second layer. And each one, like for building a wall, the second layer would be putting the studs, maybe a sheeting, I don't know, and then what else? Yeah, I don't know. So walls, maybe some electrical things go into walls. So every big task can be split into smaller tasks, and if you want the program to actually be more maintainable, more testable, we'll come to all these terms, we'll cover them in more detail later, but if you want to make your program be good for long time maintenance, then you need to make sure that these layers don't interact with each other, or only the layers on the same level interact with each other. So the very bottom layer, let's say in plumbing, right? In plumbing there is some piping, I don't know, and the plumbing task, let's say you do some piping under the sink. This function which does that should not interact anyhow with the function that says build the roof or lay the foundation or build the walls. So basically the granularity of the operations or statements in each function should be the same if these functions are on the same level. Again, yeah, this is a little more advanced concept, but we'll come back to that, I think. So yeah, I think these 5. So no code duplication, code reuse, basically ease of reading and maintenance, and then dividing or splitting tasks into smaller tasks, and finally building these layers of code with functions. These are the 5 benefits I can think of, and I think this covers pretty much all the others. There are some variations of each one, and we don't need to know. Basically, this gives you an idea. So again, function is a piece of code. In terms of source code, it's like one piece of code somehow wrapped in some special syntax which makes it invocable. So you can pass some input value or values, get some output, optionally both. Some functions might not have input, some functions might not output anything or return anything as a result. And that's it. And then anywhere in your program you can call this function. Call or invoke, those are the terms used to meaning that the program would go and start executing the code in that function. And yeah, that's it. So let's go in the next video, let's cover how we create functions, how we define what the functions do, and then finally how we say how we invoke the functions from within the program. Yeah, that's it. Thank you. See you in the next one. Bye.